Okay, the law of cosines will help us solve some triangles that are non-right triangles where the information that we are given is either side angle side or side side side. So those two cases we're going to use the law of cosines. Essentially what's going to happen when you use law of cosines is you cannot set up a proportion like we did with law of sines. So I'm not going to be able to use an angle and the side length across from it. I'm going to have to use a different strategy, and that is the law of cosines. So we've got the information here. I've got angle A, side lengths B and C. So I'm just going to draw a triangle, not to scale at all. I'm going to call it ABC, just so I know what I'm looking at here. I've got that angle A is 46.5 degrees. Side length B, so across from angle B, that's 10.5. And side length C, across from angle C, is 18. So as you can see, what I'm given is side angle side, and I don't have a side length and the angle across from it. So like I said, I can't do law of sines. I'm going to have to do law of cosines. If you are given an angle, so if we're doing the law of cosines in the side angle side case, you are going to start with the formula that includes that angle. So because I have angle A, I'm going to use this one. Okay. If I had angle B, I would use this one. But the main difference between these three is that whatever angle you are given, that is the formula is written for that side length. So notice it's a squared equals. So the first thing I'm going to be able to find using the law of cosines here is my side length A. All right. So I'm just going to go ahead and write this formula, fill out these values. But I've got a squared is going to equal b squared, so that's 10.5 squared, plus c squared, so plus 18 squared, minus 2 times b times c, so again just using those side lengths again, times the cosine of angle A, which is 46.5. Now all I have to do to solve for A is take the square root of both sides, right? So I'm going to, in my calculator, all at once just type that in. So my side lengths are 10.5 and 18, and my angle is 46.5. So I'm going to do the square root of 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times the cosine of 46.5. Now this is 46.5 degrees, so I want to make sure that I'm in degree mode. I'm currently not, so I changed that. Notice my answer changed. 13.2. So that is side length A, 13.2. Okay, now I have all three side lengths. Now I need to find the angles. So I could choose to solve for angle B or angle C, doesn't matter. But what I want you to notice is that if I'm trying to solve for an angle, I have to have all three side lengths. I have to have side length B, side length A, and side length C. So the only way I'm going to be able to solve for an angle is if I have all three side lengths already, which I do at this point in time. So I'm going to attempt to solve for for angle B, which means I'm going to write my formula where the side length B is by itself. So I'm going to do 10.5 squared equals side length A squared plus side length C squared minus 2 times side length A times side length C times the cosine of B. Now I have to solve for this angle, which means there's a lot of stuff that I've got to do here to get that by itself. My recommendation is going to be that you learn how to manipulate the formula to get the angle by itself. Okay, so I'm going to kind of go through that those steps and show you what that looks like, but then kind of hopefully you understand the shortcut of manipulating this formula to get that angle by itself. First of all, don't just try evaluating all of this stuff and calling that a single number times cosine B. You can't do that because this is subtraction here, and then I've got multiplication here. So I can't subtract these numbers, this product, from this sum until this number is multiplied by cosine. I can't do that. So do not try to get all of that into a single number. What I'm going to do is I'm going to move stuff over to this side. So I'm going to have to subtract this and subtract this. Those are going to be my first two steps. And I'm just going to show that without actually evaluating. I'm going to subtract over the 13.2 squared, and I'm going to subtract over the 18 squared. Now, what I would have left on the right side of my equation would be this negative 2 times 13.2 times 18 times the cosine of b. So because it's all multiplied together, I'm then going to divide that over to the other side of the equation. So this is going to be divided by that product of negative 2 and 13.2 and 18. Right? So I subtracted the 13.2 squared and the 18 squared, then I divided by this stuff that's multiplied by the cosine. Now that is still equal to the cosine of b at that point in time. I haven't gotten rid of the cosine formula yet. So the way I get rid of the cosine formula is I do inverse cosine. So I'm just going to do, at this point in time, inverse cosine of all that stuff. And I'm just going to type it into the calculator exactly like that. You could work out just a little bit at a time and actually get those values, but if you understand how to just move the information to the other side, I don't need to go through, well, what is 10.5 squared and what is 13.2 squared and so forth. I just know that I'm going to have this. So what did this actually be like? How did this come about? Essentially what you're going to do is whatever angle that you're looking for. So I was looking for angle B. I have that thing squared. So the side length B squared, 10.5 squared, minus the other two side lengths squared, divided by negative 2 times the other two side lengths. So notice the 13.2 and the 18, those are used twice. The 10.5 is only used once. So in Desmos, I'm going to go in here. I'm going to get my inverse cosine function. I'm going to go ahead and make it a fraction. The side length that I use only once is side length B in this case. So I'm going to do 10.5 squared minus 13.2 squared minus 18 squared divided by negative 2 times 13.2 times 18. And again, I am in degree mode. That matters. I'm in degrees, so this is in degrees. 35.3 degrees. Okay, so angle B is 35.3 degrees. Okay. Now, once I get that angle, the last thing is really easy to find, and that is simply to just subtract those two from 180. So I'm going to do 180 minus 35.3 minus the angle that was given, which is 46.5. And that means that angle C is 98.2. Right? So C is 98.2 degrees. So I've got all three angles. All three side lengths. That triangle is now solved. Again, I would recommend understanding how to do the manipulation of the formula so that it doesn't take you a long time, which could be a confusing process as well, to just understand how to quickly manipulate to get what you want. This little disclaimer at the bottom here is basically saying once I found side length A, I had a proportion that I could set up because I had the angle and the side length across from it. However, you do have to be worried that you're creating that ambiguous case of law of sines without knowing it. So I would just say be careful. My suggestion is if you're given side angle side or side side side, just do law of cosines the whole time and don't try to go to law of sines at all. Just stick with law of cosines the entire time. Okay. All right, side side side. Again, another triangle, not to scale at all. Angle A, angle B, angle C, and I'm just given the side lengths. Side length A is 5, side length B is 8, Side length C is 12. Solve for whichever angle you want to. So let's say we want to solve for angle A. I'm going to do that quick manipulation of this formula. So I'm going to say that angle A, let's see if you can follow here, angle A is going to be the inverse cosine of side length A squared minus the other two side lengths squared, so minus side length B squared minus side length C squared, divided by -2 times the other two side lengths. That's the manipulation of the law of cosines formula to get the angle by itself. Okay? To get the side length by itself, I just had to take the square root. That was much easier. That's what I did in blue right here. But this time I had to solve for an angle, so I'm just going to do this. And again, the side length that matches the angle, that's the first one at the top, and then I only use that once. I use the other two twice. So in this case, angle A is going to be the inverse cosine of 5 squared minus 8 squared minus 12 squared over -2 times 8 times 12. And I can just go to Desmos and do that. Again, find my function here, inverse cosine. 5 squared minus 8 squared minus 12 squared over -2 times 8 times 12, and I get 17.6. That is the angle A, 17.6 degrees. Now, if you understand what the change is then, so I've got that A is 17.6. Now I need to find another angle. So let's say I go for angle B. Well, for angle B, that means I'm going to do the exact same thing, but now side length B is what I use only once, and it goes first. So essentially this 8 is going to come over here to where this 5 was, and the 5 is going to go here. 12 is still there, and then also on bottom I'm going to switch that out for the 5 because I'm going to use A there. Sorry, not squared. -2 times 5 times 12, right? So the side lengths that I used twice are side length A and side length C. I only used side length B once, and it was at the beginning there. So that 5 is going in place there, and the 8s are going there, if that makes sense. Once you understand that, using the law of cosines is very easy to manipulate that formula to know what to plug in. That's why I strongly recommend learning how to do that. So all I need to do here in my formula is replace the 5 with 8. Make sure I replace both of these 8s with a 5, and I get essentially 29 degrees here for angle B. And so then to find angle C, I could do the law of cosines again, or I just need to do 180 minus 29 minus 17.6, and that will give me angle C. So 180 minus 29 minus 17.6 gives me 133.4. And I've got all three of my angles. I was given all three side lengths. I have now solved that triangle. It may seem weird that angle C is much larger. Again, keep in mind the triangle that you draw is not to scale. Think about this. Side length C was relative to A and B much larger. It's over double what the side length A is. But it should make sense that at least check to make sure that your angles are in the same order as your side lengths in terms of size. And that would be a quick check to make sure that yes, you are doing it correctly.